Find the head loss H sub L in feet. In this problem, 500 gallons per minute flows through a 6-inch diameter pipe, which is 500 feet long. The temperature of water and the pipe roughness are also provided. A head loss equation for flow through a pressurized pipe is the head loss equals the friction factor times the length divided by the diameter times the velocity squared divided by 2 times the gravitational acceleration. The problem statement provides the length and the diameter, and we also know the gravitational acceleration. So we need to determine the friction factor and the velocity. The average velocity of flow, v, equals the flow rate divided by the area. The problem statement provides the flow rate, Q, which will convert to cubic feet per second. The area is a function of the diameter. The diameter is converted to feet and then substituted in. After solving for Q and A, we compute 1.114 cubic feet per second divided by 0.1963 square feet, and the velocity through the pipe equals 5.673 feet per second. With the velocity calculated, the last remaining variable is the friction factor, F. The friction factor is a function of the Reynolds number and the relative roughness. The relative roughness equals the roughness length on the inside of the pipe, epsilon, divided by the inside diameter of the pipe, d. Since both of these values have been given, they are substituted into the equation, and the relative roughness equals 5 times 10 to the negative 5. The Reynolds number equals the velocity times the diameter divided by the kinematic viscosity. The kinematic viscosity is a function of the water temperature and can be looked up in a table. Since the temperature is 50 degrees Fahrenheit, the kinematic viscosity is 1.410 times 10 to the negative 5 feet squared per second. After the velocity and diameter are plugged in, the Reynolds number equals 2.012 times 10 to the 5th. With the relative roughness and the Reynolds number, we'll last return to the Moody diagram and determine the friction factor. The Moody diagram relates the friction factor to the Reynolds number and the relative roughness, where the left part of the diagram is used for laminar flow and the rest of the diagram for turbulent flow. Since the Reynolds number in the problem is more than a few thousand, the flow is turbulent. In the diagram, each curved line represents a constant relative roughness value, where the bottommost line is considered a smooth pipe. To find the friction factor, we'll find the Reynolds number on the horizontal axis, then trace up to the relative roughness contour equal to 5 times 10 to the negative 5. Then trace left to the vertical axis to find the value of F. For this problem, the friction factor is most nearly 0.016. If reading the Moody diagram is difficult, these values can also be looked up in published tables. By knowing the friction factor, the head loss through the pipe can be calculated. The variables are substituted into the equation, and the head loss equals 8.0 feet. Looking over the possible solutions, the answer is B.